Everybody. My name is Henry Evans and I am a mute quadriplegic speaking to you from my bed in Northern California. I guess it takes a stroke to get to bring your bed to class. Seriously, though, Dr. Picard asked me to talk to you today about my experience with building assistive devices. I have spent the last 10 years thinking about what I wanted assistive devices to do and then cajoling smart engineers into building them. Over the years I discovered which general criteria make for truly helpful assistive devices, and the objective of my talk will be to share my learnings with you. In order to bring those learnings to life, I am first going to show you videos of 10 of our projects which reached the working prototype stage and ask you to rank them by how successful they have been at improving my daily life. I will then introduce my criteria, and give you my own ranking. As you compare your rankings to mine, hopefully you will learn some things which will help you improve your designs for assistive devices. So without further ado, let's go to the movies. Please rank each item on present usefulness. The first device actually performs several tasks around the house for me. It uses the PR2 robot from Willow Garage, as well as software developed jointly by Willow Garage, Washington University in St. Louis, and Georgia Tech in a project called Robots for Humanity. Let's watch. In the following videos I am the only person giving the PR2 movement commands. For control purposes I use a commercially available head tracker that converts my head movements into cursor movements by tracking a reflective dot on my glasses. When the cursor is over the target, I have just enough thumb movement to click a simple switch, which selects the item. I type this way using an on-screen keyboard. Basically I can do most of the things a normal person can do using a mouse, only 10 times more slowly. Watch as I do a Google search for CalTech. I slowly type in the search term until it predicts CalTech. I then select it and hit return. In order for me to use the mobile manipulator as a body circuit, the teams from Georgia Tech, Washington University and Willow Garage developed a control GUI, shown on the right half of the screen. Following are some of the things I directed it to do. You will notice me using several different custom GUIs. We also visited a local mall, so I could hand out Halloween candy. In addition to using the PR2 locally, the web-based system enabled me to remotely pilot it. Here I am shaving Dr. Kemp in Atlanta, over 2,000 miles away. So that is the first project, the PR2. Our second project is called Auto Treat. It was developed so I could have some interaction with our dog, Amber. Before, all Amber did was lie by my side, staring blankly into space.
Hello everyone. Our Year 11 computing class was contacted by a man by the name of Henry Evans from America, who challenged our squad to design a dog-feeding assistance device that was operated wirelessly from a laptop. Our device was based on a motion-activated gumball machine, which we had to completely disassemble in order to be operated wirelessly. We connected a Raspberry Pi, which is a hand-sized computer, to a relay. The relay, when activated, triggers a switch to activate the motor, which dispenses the dog food. Several students in the class designed a custom application which allows a computer to communicate with the Raspberry Pi wirelessly through a router. We will now demonstrate the operation of our device.
So that was the second project, Auto Treat. The third project also uses a Raspberry Pi, and is called ScratchBot. What you are looking at here are the web pages which are wirelessly generated by the miniature computer in the ScratchBot. The images allow me to control the scratcher without assistance. I just point to the image of the commands with my head tracker and then click a simple switch. Here I am wirelessly directing it to my head. It greatly enhances my independence because no caregiver is needed. It feels great. So that was the third project, Auto Treat. The fourth project, Laserfinger, was prototyped with a $10,000 grant from Linus and MIT. We all flew to MIT to present it, and were introduced by my daughter.
My name is Michaela Evans, and I'm Henry Evans' daughter. My dad is a quadriplegic mute patient due to a brainstem stroke, and he asked me to say a few words on behalf of him. Several years ago, someone gave my dad an environmental control unit which cost $5,000. It was an impressive piece of equipment. It was a box that plugged into his computer. It emulated all of his electronic devices and software so he could operate them through X10 and infrared interfaces. At first, he thought it was brilliant. He was able to make phone calls, change the TV channel, turn on the lights, etc. However, he put it away after 3 times and realized why it had been discontinued as a commercial product, and also why it was apparently being regifted so much. The engineers had overlooked a crucial step. They failed to consider the environment their device was working in. To really understand my dad's situation, lie down in your bed with your arms and legs tied behind your back. Remember, you can't speak, and the only thing you can do is nod your head. Then try to turn on the light across the room, with no help whatsoever. This was his dilemma. What he wanted was a little independence, not some over-engineered masterpiece no one wanted to use on a daily basis. His head tracker worked well, and he mistakenly thought it used a laser. All ideas lay dormant for 2 years until we moved back to California and Chris paid a visit. They had met at a startup, and he had originally come to intensive care. Dad described what he wanted, and Chris said he and the team would think about it. And I hope you are as pleased with the solution as my dad is. Thank you.
Hi everybody, my name is Daniel Schaefer, and we're here on behalf of the Pally Invent team. I'm joined on stage today by Mike Tramiel. And so I give you our invention for this year, Laserfinger. What we've done on the high concept level here is we've taken a laser pointer and we've put it on Henry's head. And here to talk about the technologies we've used is Mike.
Okay, so first our laser pointer, we actually have a schematic of what the circuit is we made. it isn't just a laser. We made a bunch of printed circuit boards that are on Henry's head right now. So if you look at that, next we have the actual physical board, which is printed out on. And there's the finished product. If you see, the gold ball is actually a tilt switch. So when Henry tilts his head, he can control whether the laser is on or not. So since first, he's not always blasting people in the eye with the laser, and second, the batteries last long because it's only on him when he needs it. And also the batteries are right there. The whole thing's very small and compact, and it's right on his head.
Now, we have the laser. It's up here. This is our printed circuit board. We decided to do something a little nicer for Odyssey, and so we went in SolidWorks and we designed this enclosure. And then we sent it to our 3D printer through a partnership with the tech shop, and it came out, it looked like this. We laid down just thin layers of ABS plastic, and here's what it looks like when it's done, and we really like it. Now, what we've done with it, we've put magnets on it so it sticks to Henry's hat or his glasses. Now, let's audience participation here. When was the last time you in the audience turned on a light, flipped a light switch? Today. Henry? Now, Henry, when was the last time you turned on a light? We have not only the laser pointer, but we're also demonstrating receiver technology, which we can get into now. Mike?
What you're seeing here is an open box picture of our main light switch. If you look in the very front, there's a solar cell, and all that really is doing is when he points the laser at it, it gets a little more power. And we custom designed a circuit that filters out all the other light with that laser, then amplifies it and sends it to our PIC microprocessor, which that realizes that if it's the signal from our specific laser, then it'll turn on and it'll tell the light to go. Henry, if you could turn that light off for us.
Okay, that was laser finger. In fact, you can see it on my hat in this picture. The next item, number 5, is actually a byproduct of the PR2 project which is being conducted at Georgia Tech. It also uses a Raspberry Pi to project a GUI on my computer so that I can click on it and adjust my own hospital bed whenever I want. And of course it is also wireless, except for the power cord. I just need a standard web browser. And that is AutoBed. Another idea came to me when I wanted to go outside and see my yard. It struck me that all I needed were my retinas, not my whole motionless body. So I randomly posted on the internet that I needed a volunteer engineer to modify a camera drone so I could fly it with my head. 2 people built solutions. Dr. Jenkins of Brown University and Brian Galusha from a drone company named Fighting Walrus. The 6th project is the drone which Dr. Jenkins modified after hearing of my request. In addition, he designed it with the control GUI on a web page so I could fly it in distant cities using a standard web browser. The TEDx talk we did with it got over 1 million views. Chad showed me how easy it is to purchase and fly aerial drones. It was then I realized that I could also use an aerial drone to expand the worlds of bedridden people through flight, giving a sense of movement and control that is incredible. Using a mouse cursor I control with my head, these web interfaces allow me to see video from the robot and send control commands by pressing buttons in a web browser. With a little practice, I became good enough with this interface to drive around my home on my own. I could look around our garden and see the grapes we are growing. I inspected the solar panels on our roof. One of my challenges as a pilot is to land the drone on our basketball hoop. I regularly fly drones around his lab several times a week, from my home 3,000 miles away. I never thought I would be able to casually move around a campus like Brown on my own. I just wish I could afford their tuition. Okay, that was Chad's drone control system. Next, let's look at the FPV control system Brian built using an Oculus Rift. The next item is near and dear to my heart. It's called WhiskeyBot, and it was built by my nephew at NYU.
This innovative machine uses the EEG to detect blinking for control of a revolving straw and whiskey pump. Henry is able to sip single malts just by blinking to activate it. Let's watch. Whiskey straw. EEG. Robots don't have to be evil. I'm Henry Cleaver, and I build robots for humanity.
The next device was not actually developed by robots for humanity, but I include it here to make a point. It allows me to drive a power wheelchair with my head. It is a head array mounted in place of the headrest on my power wheelchair. It has proximity switches on both sides of and behind my head. I steer and control speed by moving my head slightly and tapping a particular proximity switch. It works well. The last device was also developed by the same individuals who developed PR2, and although I had nothing to do with developing it, I did help figure out how disabled people could benefit from it. It is a telepresence device called the Beam by Suitable Technologies. The following 1-minute video describes how I use it.
The Beam has helped us as a family because when you have a member of your family that has lost everything, movement, speech, so he's literally trapped in his body, the Beam is actually taking Henry to places that he could never go to.
Once the Beam is set up, I can log in and go for a walk anytime I want, with no help from others, even if the Beam is physically located on the other side of the world. Call it the democratization of culture. It's the closest I have come to walking in the 11 years since my stroke.
The Beam has taken Henry from a man that has locked-in syndrome to freeing him to go visit people, interact with people, and what that means is it freed him up mentally from his body. He's doing what he loves. He's living his life.
And that completes the list of our 10 devices. To remind you, here is the list. Now, using this list to prod your memory, please finalize your ranking from least to most useful. Let's take 30 seconds, starting now. Okay, let's begin. Although there are no right answers because every disabled person's situation is different, hopefully my criteria and their application to my particular situation will be instructive as you design your projects. To keep things simple, I only have 2 criteria. The first one is rather obvious, the second one not so much, but it is extremely important. The first criterion is one of independence. The device must increase the independence of the disabled person. Unfortunately, there are problems with this criterion. First, it is pretty obvious, and just about every well-designed project increases independence. Second, it is a necessary, but not sufficient, condition. So let's dig a little deeper and find the criterion that will help us with the usefulness ranking. To rank these 10 projects by real-world usefulness requires criterion number 2, which took me a couple of years of careful observation to figure out. I call it the caregiver principle, which holds that no matter how much assistance a device provides to a patient, it will not be used regularly unless it also takes no time to either set up or used by the caregiver, and unless it makes the caregiver's life, net, a lot easier. Using these two criteria, while placing particular emphasis on the second one, we can rank the projects by real-world usefulness. They fall into 3 groups. Red, which I do not regularly use, yellow, which I could imagine using regularly, if the prototypes were completed or made more robust, and green, the devices which I actually use every day to improve my life. To understand what I mean, let's look at the least used item on my list. Coming in at number 10 out of 10, based on my own situation, is the wheelchair head array. Although it is extremely well designed, and I personally love using it, I have not used it in 5 years. The reason is that my wife doesn't like wrestling a 400-pound power wheelchair into our van, and she doesn't like worrying about me when I go cruising off. You see, since I can't talk, I am stranded if I drop my mouse, and I can't ask anyone to help. In the end, it is much less trouble for her to push me in a manual wheelchair so she can keep an eye on me. Thus, although this device technically works very well, I never get to use it because it makes my caregiver's life more difficult. It probably gets used a lot by people in a different situation, just not in mine. The next 2 devices are timed because they are so closely related. Let me point out that they are also the most fun and make for the best demonstrations. But as far as helping my caregiver goes, they don't rank very high. I am talking, of course, about the 2 drones. In fact, my caregivers can't even set them up. When TV stations call and ask to film the quadriplegic flying a drone, we have to arrange for a couple of able-bodied super techies to set everything up and continually troubleshoot. Otherwise the drones just sit on my shelf. Because they actually require assistance from my caregivers, and do not make their lives easier, the drones see no use on a daily basis. For these reasons, the drones are in 9th place, and still red. The next device does help my caregiver by keeping the dog up from underfoot, in addition to keeping me entertained. It does not require much human assistance, except for occasional refilling. I am talking, of course, about Auto Treat. Unfortunately, I have not been able to test it because they never mailed it to me after they built it, but from the video, I would rank it number 8, and color it yellow because it does help my caregiver, albeit marginally. The next device appears to be completely whimsical, but part of it has real potential for helping me independently control my environment. Coming in at number 6 is the Whiskey Bot. The switch is the technically interesting part. Severely disabled people often interact with the world by clicking a single switch. This setup utilizes the wireless EEG sold by the company Emotive. My nephew Henry Cleaver, from NYU, discovered that a purposeful blink generates a very distinctive waveform on even a single $20 sensor. By altering the number of purposeful blinks from 3 to 5, I am able to toggle between phases 1, 2 and 3 and back to 1. In this application, the phase changes are connected to stages on the Whiskey Bot. The end result is that I get to set my libation of choice just by blinking my eyes. Let's watch it again in slow motion. If you look closely, you can see me blinking. To bring the tube to my mouth, I blink purposefully 5 times, going from phase 1 to phase 2. Then I blink 4 times to turn on the pump, going from phase 2 to phase 3, and tasting the nectar of the gods. Finally, I blink 3 more times to switch off the pump and return the tube to phase 1, its base position. There is no reason the switch sensor could not be made to be highly ergonomic and assist my caregiver by enabling me to switch electrical devices on and off independently. Speaking of switches, the 5th device is also a switch used by the severely disabled to independently control anything electrical in their environment. It is laser finger. Because it mounts on my glasses, and I turn it on myself with a tilt switch, there is nothing for the caregiver to do except put my glasses on, which they do anyway every morning. although it is well designed, in that it makes me more independent and decreases the number of things my caregiver has to do. I only rank it number 5 because the prototype broke after 2 weeks and I have not been able to use it ever since. The team graduated, and no one has taken up the mantle. Coming in at number 4 is the PR2 project at Willow Garage in Georgia Tech. It's still yellow, because as of the date of this presentation, my caregiver is not permitted to let it run independently, although that is the goal. It is number 4 because it has a lot of potential, and because its development led directly to each of the top 3 projects. Green indicates that I use the device every day in its present form. The top 3 devices are all in this category. Number 3 is the ScratchBot, the relatively simple device that sits behind my computer and, at my command, reaches down and scratches my face. The only reason it doesn't rank higher is because when my caregiver is in the room, it is slightly easier and quicker to have them scratch my itch, although when they're gone, ScratchBot gets used constantly. Coming in at number 2 is the Beam Telepresence device, which was developed by some of the same engineers who built PR2. I can operate it anywhere in the world with no assistance from my caregiver. I use it primarily for 2 purposes. First, I have one in my home that I drive around the house several times a day to find and then summon my caregiver. My ability to do this gives my caregiver peace of mind. Second, I visit places all over the world, from Seoul to Barcelona to CalTech without leaving my bed. People also visit me. It is remarkable. Beating the others out for the number 1 spot is a byproduct of the PR2 project at Georgia Tech. It is AutoMed. I use it independently dozens of times every day, saving my caregiver a tremendous amount of time. It is number 1 because it is the only device that my caregiver demands I get fixed when it breaks because it saves her so much time. For this reason it is the only device which is fastidiously kept in working order. So there you have it. Our top 10 projects ranked by the 2 key criteria that matter the most. Does the device improve the patient's independence? And more importantly, does it also make the caregiver's life a lot easier? Let me also say that technical complexity is irrelevant as long as the user interfaces for both the patient and caregiver are simple and intuitive. One more thing. A call to action. If you know any software engineers who would like to volunteer their time to our cause, please put them in contact with me. I hope my criteria are helpful as you selecting design your projects. Thank you.